Welcome to 1.5, Unit 1, Lesson 5, Sequences or Functions Practice Problems. Okay, match each sequence. So, here's the trick. You come over here and you find your change. My change is times 7 times 1/2, and then plus 6. So, all I got to do is find 6 plus 6 is 12 plus, so A goes with 3. 2 times 7 is 14, so that goes with that. And then 160 times 1/2 is that one. Okay, write the first 5 terms of each sequence. Determine whether each sequence. Okay, so the first thing we want to do is going to look at the change again. So -3, 2n minus 1 times 10, and then times n. Okay, so it's different. So now, this is arithmetic. Yep, I left it on. I always do that. This is arithmetic. This is neither. This is geometric. And times n. Even though it's times n, it's not the same term. Step 1 is going to be times 1. Step 2 is going to be times 2. Step 3 is going to be times 3. So this is also neither. Now, let's calculate the first term. The first term is 7. 7 minus 3 is 4, is 1, is -2, is -5. All right, that was easy. The next one, 2n minus 1. We start at 2. 2 times 2 is 4 minus 1 is 3. 3 times 2 is 6. Minus 1 is 5. 5 times 2 is 10 minus 1 is 9. 18 minus 1 is 17. Wow, y'all thought this was going to go 2, 3, 5, 7, right? Okay, next one. 3 times 10 is 300. Times 10 is, oh wait, what am I saying? 300 is 30. I'm jumping the gun. 30, 300, 3,000, and then 30,000. Okay, and then for the last one, 1. Okay, step 1 is 1. Step 2 is 1 times 2, because the step number is 2. Then 2 times 3 is 6. 6 times 4 is 24. 24 times 5 is 100. Is it 110? All right, 4 times 5 is 20, 0. Carry the 2, 120. Okay. Yeah, 20, yeah, 120. All right, that was tricky. Yeah, remember, times n, it changes. Okay, here, the first 5 term of some sequences given, state a rule. 2 plus 2 is 4 plus 6, so that's plus 2. 5, 7, 9, that's also plus 2. 50, 25, 0 says, so that's minus 25. And then 1/3, 1, 3, 9, 20. Oh, that's times 3. So the first thing you do with sequences is figure out the change or the growth factor. A function f is defined by f of x equals 2x minus 7, and g of x is defined by g of x equals 5x. Okay, so for A, we're going to do A in, what color are we going to do? A in pink. And we're going to do B in green, G in green, or F in G. All right, so let's do, so f of 3 equals 2 times 3 minus 7. 6 minus 7 is -1. F of 2 is 2 times 2 minus 7 is -3. And if we see the pattern, It's going down by -2 because that's our slope. Let's just put it in. 1. I'm sorry, I'm going backwards. 2 times 1 minus 7. 2 minus 7 is -5. And then f of 0 is 2 times 0 minus 7, which is -7. And then f of -1, 2 times -1. Whenever you substitute, use parentheses. Is -9. Whenever you substitute, use parentheses to keep your sign straight. And we're going to do G, so that was F. So G, let me put this in the calculator. So G of 3 equals 5 to the 3rd power, which is 125. G of 2 equals 5 squared, which is 25. G of 1 equals 5 to the 1, which equals 5. G to the 0 equals 5 to the 0, which equals 1. G to the -1 equals 5 to the -1, which equals 1 over 5. We're going to come back to all of this when we get to exponent laws. Okay, here are the graph of two sequences. So we're going to call sequence A orange and sequence B blue. No, wait, they got A in blue, so let's change the colors. Let's make A orange. No, but I did it again, didn't I? Let's make A blue and B orange. That's what I wanted to do because these dots are already blue. So now let's find the dots. Blue, why'd I do that? So here go the dots. Blue, 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 blue. Okay, so all you got to do is figure out the Y values. The Y values are your outputs. Here are your inputs right here. So, in blue. All right, 0 is -1. Go over 1, we're at 2. Go over 1, we're at 5. 2, 5, 8, 11, 14, 17. The change is +3. This is an arithmetic sequences, and we can see a straight line. So we know that arithmetic sequences are linear, so this is linear. Okay, so now for the orange one, sequence B, just find the numbers. 1/2, 1, 1 is 1. 2 is 2, 3 is 4, 5, 4 is 8, 5 is 16, and then it's 32, but we don't see 6 here. But we know that the pattern is times 2, and it's geometric, and we know it's geometric because it has a curved sequence. I couldn't fit the rest of the questions for number 5. You'll see more questions on your slide, but I already answered them. So thank you for watching this video.